And I'd like to welcome you all to the Making the Move from Mathcad to Mathcad Prime 2.0. I'd like to advise everyone that today's presentation is being recorded for replay purposes. There's just a few logistics before we begin. You can listen to this presentation using your computer speakers or by dialing in using the audio information under the audio section in your toolbox. We will be answering all written questions at the end of the presentation. You can type your questions in the Q&A section in your toolbox. I would now like to turn the call over to Angie Severino, Mathcad Senior Applications Engineer. You can go ahead, Angie.
Thank you, Deb. Good morning, everyone. I'm Angie Severino, and I will be conducting the presentation this morning. So today's presentation will last about 1 hour, and then at the end of the hour, we'll open it up to Q&A, and so we'll take Q&A for about 10 to 15 minutes following the 1 hour presentation. So that being said, let's go ahead and get started. Today's presentation is titled Making the Move from Mathcad to Mathcad Prime 2.0, and we're going to be focusing primarily on Mathcad Prime 2.0, what's in Mathcad Prime 2.0, and how you would migrate from your existing use of Mathcad into Mathcad Prime 2.0. So, very briefly on the agenda, we're going to start off with a Mathcad Prime 2.0 review for those of you who have seen it before, or an overview for those of you who are new to it. We'll go through some of the new features and new capabilities in Prime 2.0. We'll talk about converting your legacy worksheets into Prime. And at the end, like I mentioned, we'll have a Q&A session. So, hitting the first item on the agenda here, Prime 2.0 review/overview, I'm going to take just a few minutes to go through what Mathcad Prime 2.0 is all about. So, this file that we're looking at right now, the presentation material that you have on your computers, is a Mathcad Prime 2.0 document. Okay, so this is Prime 2.0, and you'll see that it looks very different from classical Mathcad. Classical Mathcad being Mathcad 15, 14, 13, 12, and before. So this looks very different. The user interface in Prime is completely redesigned. So when we architected Mathcad Prime, and so that's all inclusive, Prime 1.0, 2.0, and going forward, when we architected Mathcad Prime, we decided that we needed to build an application that's incredibly intuitive. So we architected Mathcad Prime with 3 primary objectives in mind. So the first objective is that we wanted Mathcad Prime to be extremely intuitive. We wanted it to be easy to use, and within 15 minutes, any engineer should be able to model a simple engineering problem in Mathcad. So that would mean defining some variables, defining some formulas, writing down some equations, and perhaps creating a 2D plot of some sort. So within 10 to 15 minutes, you should be able to do all of those things. That's how intuitive we wanted this application to be. So that was the first objective. The second is that we wanted to make it incredibly easy, and I guess I could write this down, to integrate with data sources, other files, other applications. So, so it should be easy to get data into Mathcad from Excel, from spreadsheets, and it should be easy to get data out of Mathcad, so out of Mathcad into other applications. And the third item is that we wanted to give Mathcad a very document-centric type of feeling to it. So that being said, we've added many documentation functions and features to make it such that we can create our final engineering documents, publication quality documents within Mathcad Prime itself without having to export our Mathcad content to another application for publishing and distribution purposes. So we've really focused on the documentation side of things and the publishable quality of the documents that we're creating. And you'll notice that as we go through the presentation, but I'll also point out some of those capabilities as well. So I'm going to write document-centric focus. Okay, so these are some of the themes that went into Mathcad Prime. Okay, it should be intuitive, easy to use. It should be easy to integrate with other data sources or applications, and it should have a document-centric focus to it. Okay, so we don't want engineers to have to go back and forth between a lot of different applications to create final documents that are worthy of distribution to colleagues, partners, suppliers, customers, managers, etc. Okay, so what I've done here is I've added some text items, some documentation to this Mathcad file. So we all know that Mathcad is a math engine at the core, and so there's a math engine always running behind the scenes here, and we can integrate into this whiteboard type of environment math objects, text objects, and graphical objects. Okay, so we can create these comprehensive engineering documents that integrate math, text, and graphics. So all of that is the same for Mathcad Prime. None of that has changed. But there are a lot of new features that make it easier to do that. So regarding the layout of Mathcad Prime leverages the Windows 7 ribbon user interface. So if you look at the top of this application, you'll see that all of the menu items that we had in Mathcad 15, 14, and prior, all of the drop-down menus, the pop-up menus, those have all been reorganized and consolidated into these tabs across the top of the application that resemble the Windows 7 ribbon user interface. Okay, so if we take a look at the Math tab, on the Math tab we have sub buttons or subcategories, if you will. We have the math object, we have the solve block, we have a couple of different kinds of text boxes to document what we're doing, and I'll differentiate between these two text box items momentarily. We also have our operators. So in prior versions of Mathcad, these were all pop-up windows that were floating in the workspace. So in Prime, we don't have pop-up windows that are floating in the workspace. We have consolidated all of that into this ribbon. So going to the operators, you can see these are organized by function. Here are the algebraic operators, the calculus operators, and so on and so forth. So if we wanted to put in the first derivative of a function or the definite integral, we would come over here and click on this operator, or we could also take note of the keyboard shortcut, which in this case is Control-Shift and the letter I, and that'll put that operator into our worksheet for us, and then we just fill in the empty placeholders. So these are the operators. We have the Greek characters and the Greek symbols. Those are all located here. Okay, and so if you hover over any of these, alpha, for example, it tells us what the Roman equivalent is. So we could type alpha into the worksheet, followed by Control-G, and that'll toggle back and forth between the Roman A and the Greek character alpha. These are the programming constructs. We can write programs and execute logical sequences in Mathcad worksheets, and that's called Mathcad inline programming. So this is where the programming constructs are located. These are the built-in constants. This is the symbolics engine, the symbolics engine keywords, and then we have a couple of other things here on the right-hand side, which I'll come back to. So one is style, okay, and we'll come back to that. And the other one is units. So as we know, Mathcad is a units intelligent application. So we can type in any type of expression involving units. I'm going to type in 50 feet plus 30 feet plus 50 inches plus 7 yards and hit equals, and we get a result with units. So that's one of the most compelling things about Mathcad, is that the math engine understands units, it propagates units throughout calculations, it performs unit conversions for us. We can assign this to a variable called length, and then we can display length in many different units. We can display it in inches, we can display this, maybe somebody that we're working with wants to see this length in millimeters instead of inches. So we can display it in multiple different units, and all of those unit conversion factors are built into the math engine. So the engineer doesn't have to know how to go from meters to inches, what that ratio is, what that multiplier is. Okay. So regarding units in Mathcad Prime, several enhancements have been made. Okay, the first is that you can see here that all of the units are identified by bold navy blue font in this particular document. Okay, so in Mathcad Prime, we have the ability to assign those styles to our units. Okay, so in the past, a lot of times what was happening is because Mathcad has built-in units, for example, if I type m equals without defining a variable m, Mathcad assumes that I'm referring to 1 meter. M represents the built-in unit of 1 meter. However, if I define a variable m first, let me get rid of this. If I define m and set m equal to 30 kilograms, now that's a variable that stores a mass. Now m is going to be holding a value of 30 kilograms. So what was happening is this was leading to some confusion. People were using variables in their equations that also have built-in unit definitions, and there was confusion around whether, in this case, for example, in this example, there was confusion around whether they're using the built-in unit of 1 meter in their equation or whether they're using some kind of set value assigned to the letter m. So to clarify that, we have provided the ability to associate these custom labels with or styles with your units. So if we go up here to the units, we can see that we're working in the SI unit system. So if you want to change your unit system, it's easy to do that right here. Okay, and we can also see all of the units that are built in. Okay, so they're organized by category. So you can scroll down through this list and see what the units are and what the shortcuts are to enter them into your equations or into your worksheet. Okay, so right now I'm just scrolling down. We have force, force density, force per length, frequency, and I'm only about a third of the way through the list. So here are all of the units that are built in. So once you assign your style, okay, it doesn't have to be navy blue, bold, italicized like mine is. It can be any style you want. Once you assign your style, your color, to your units, any unit that you enter in from this units menu will appear in that custom style that you've set. Okay, and I'll show you how to make that setting. Okay, so that's one improvement that we've made when it comes to working with units. And I'm going to come back to some of the other enhancements with units because I want to kind of get through the layout of the application without diving into too many specific functional areas mathematically. So let's go back to our tabs across the top. Okay, so that's the Math tab. Then we have the Input-Output tab. One thing that I said up front was a key focus of Mathcad Prime was that we wanted to make it easy to integrate with other data sources. Okay, and so the primary data source typically for engineers is the spreadsheet. So we wanted to make it incredibly seamless to import data from a spreadsheet, from a CSV file, into Mathcad. Okay, because spreadsheets are very good at storing data. They're good for storing data. They're not good for the calculations, for the engineering work that is associated with that data. So we should be able to store the data in Mathcad, sort it in Mathcad, or store the data, in the spreadsheet, sort it in the spreadsheet, filter it in the spreadsheet, do all of those kinds of things in the spreadsheet, but then reference the data and do the calculations and the engineering work in Mathcad. Okay, so those two applications have to work very closely together. And in Mathcad Prime, they do. If you look here, we're on the Input-Output tab. There are 3 buttons here at the top on the Data Import-Export category. There's Data File Name, there's Read Excel, and there's an Excel component. Okay, so if we want to import some data from an Excel file, this is extremely easy to do. All we have to do, and I can just show the hooks for it, we click on this button, and I just hit a keyboard shortcut, so let me go back over here. We click on this button called Read Excel, okay, and this will create a dynamic link to your Excel file. Okay, and so then we browse for our Excel file, and so we would just browse for our Excel data. And so let me find my Excel data here. And so here, we're just going to select our data file. It lets us preview the data. Okay, we can look at sheet 1, sheet 2, sheet 3. We can select a subset of the data if we don't want the entire data file. It'll automatically specify the columns and the rows, so the range basically. It shows us that this is coming from sheet 1. And so I'm just going to leave that as is and click on Insert. And so Mathcad automatically puts in this read Excel function and reads in the data. And now we're going to assign it to a variable called data. And that stores all of the data coming from sheet 1 of that spreadsheet, range A1 to H5. Okay, so now if we want to see it, we can see it. And once that data is in Mathcad, we can start to dissect it and use it in our equations and our calculations. We can plot the data, we can interpolate it, and build our math models using the data. So that was about a 5-second process. Okay, it's incredibly easy. And it's linked. So if that data file changes, then Mathcad is automatically going to process the changes. So that data file could be on a network share, it could be on your own local drive, it could be anywhere that you have visibility to it. And Mathcad will always read the latest data set. So that's the read Excel function. So again, this is new in Mathcad Prime. This was not in Mathcad 15. You could certainly import data from Excel in Mathcad 15, but not like this. Okay, you couldn't do it with the click of a button like this and automatically have the path, the sheet number, the range, the whole expression put automatically into your worksheet with the read Excel function. So it wasn't that tight of an integration. The other thing that that Mathcad Prime has, as far as, I'm going to the next page here, as far as importing data from Excel, is called the Excel component. So the Excel component behaves a little bit differently than the read Excel function. The Excel component will actually embed an instance of an Excel object inside of your Mathcad worksheet. This is very slick, and it lets you have inputs and outputs to the Excel object. Okay, so you could send data into the Excel file, and you could get data out of the Excel file, and it's all embedded inside of your Mathcad document. It's actually pretty cool. So, so to put in the Excel component, you click on the Excel component. It puts in the component for you, and then it gives you an area to define your inputs, gives you an area to define your outputs. So if you double click on this object, it's going to activate Excel. Okay, and in this case, this Excel object is empty. So let's just double click on this. We're going to activate Excel. And now I'm in Excel. Okay, I can do anything I would normally do in Excel. I'm just going to put in some random numbers here. We'll just put in some totally random numbers. Okay, so there's some random numbers in this Excel file. Okay, we could put in formulas, we could run macros, whatever we want to do. I'm going to close this, and this 2x2, basically A1 to B2, is automatically going to go into my Mathcad file. So I'm going to close this. I don't have to save this file. Just going to close this. Okay, and so now we can see the data there. Okay, now here's where this gets very, very useful. Okay, so now we can send inputs from our Mathcad file into this Excel object. So we had, let me just write an equation. Let me just say A is going to be have a value of 78. B is a variable that has a value of, we'll put units on these. We'll put 78 centimeters. B will have a value of 90 centimeters. And we'll just calculate C. Okay, we'll just say C is the square root of A squared plus B squared. Okay, and so there's the result with meters. And going back to the units, you can see the unit styles. Okay, and let's just say we want this in millimeters. Okay, and now we want to write the value of C into this spreadsheet. Okay, so what we're going to do is we're going to set an input to the spreadsheet. Okay, and so I'm going to say Excel, and then let's write it into the location C1. Okay, so C1 is the location, and that's going to hold the value of the variable C. Okay, and so there it is. And so that's how we write inputs into the Excel object. Okay, now if that value for C changes, for example, if A, one of our driving variable, changes from 78 to 88, obviously C is going to update, and what's stored in the spreadsheet is going to update as well. Okay, so now C is 1.259, and that's what gets written into the spreadsheet. Now let's double click on the spreadsheet. Okay, and now we can do whatever we want to do in Excel, and we can close this, and we're back in Mathcad. So the output works the same way. We can read data out of Excel back into Mathcad. Okay, so this is very, very useful. Okay, we can do a lot of calculations in Mathcad. We might end up with 5 or 6 data vectors of results. We can send those 5 data vectors into an Excel object like this seamlessly. Let Excel build a pivot table. Let Excel do a sort. You know, you can do sorting and filtering in Mathcad as well, but it's probably more straightforward to do it in Excel. Let Excel do those kinds of things, and then read the sorted data back into Mathcad and create the plot. Okay, so that's one example of why you would want to do something like this. So that's the Excel object. So again, the point here is that this is actually this structure, this Excel component structure is new in Mathcad Prime 2.0. Mathcad 15, 14, and prior did have an Excel component. It did not work like this. Okay, it didn't work like this. For one thing, that when you double click on this Excel object, it launches Excel as an out-of-process application. It doesn't launch it in process. In Mathcad 15 and before, it was launched inside of the Mathcad document. Okay, so you couldn't work in Mathcad and Excel at the same time. This is out of process, so it's a different implementation, and it's a lot better. Okay, a lot better. And so let's move on. That's the Input-Output tab. Let's go to the Functions tab. The Functions tab has a collection of categories at the top. If you want to see all of the functions, you can click on the All Functions button. It's going to post the function panel on the left-hand side. You can move that to the right side if you want. There's a search window. All of these categories can be expanded, so if you wanted to expand the solving category, you can see all of the built-in functions for solving. So there's the ordinary differential equation solver, the find function, maximize and minimize for optimization. If you're doing some optimization, you would use those functions. It tells you what the arguments are and a brief description of what that function does. Okay, and then if you want further help, you can always go to the help pages. Okay, so those are the functions. That's the function tab. So I'm going to, you can leave this up obviously, or you can close it out. Let's close it out. So let's keep going over to the matrices and tables tab. A lot has been added to Mathcad Prime 2.0 in regards to matrices, and specifically there's something new called data tables. Okay, so I'm going to pause here before we go on to the other tabs here, because there's some very important things in Mathcad Prime 2.0 that are new that are worth pointing out. Okay, so first of all, we've always had matrices in Mathcad. Okay, we've always had matrices or arrays. Some people prefer to call them arrays. A matrix is essentially a 2D array. We've always had those in Mathcad. In Mathcad Prime, we have matrices. However, there's a few changes that have been made, a few enhancements. Okay, so I'm going to just put matrices here. New features, I suppose. Okay, so the first is that in Mathcad 15, 14, and I believe 13, prior versions, you could not have mixed dimensions within a matrix. So, for example, if we create a matrix here, we just create a 4 by 2. Okay, we could have entries here, but when working with units, they all need to come from the same dimension. So if we're working with the dimension of length, that would need to be 50 inches. This could be 30 feet. This could be 20 yards. You know, these would probably most likely all have the same unit because they're in one column of numbers. But just for discussion purposes, we'll give them different units. They all need to come from the dimension of length. So then here, this would also have a dimension of length, okay? So this would also have to be some kind of length, so 60 millimeters, 40 centimeters, and so on, okay, 30 inches and 2 meters. Every entry in this matrix comes from the dimension of length, okay, and this was a requirement in older versions of Mathcad. So perhaps a better example would be, because this would be more similar to how we structure our columns, this would probably all have inches, okay, and this might all have some other unit, okay, centimeters. Okay, so this is probably more likely. Even in this case, everything comes from the dimension of length. So in prior versions of Mathcad, in order to use this data, you would have to first we're assuming we're bringing this data in from some other source. We'd import the data, we'd pull out the columns, we'd assign the units, and so the we'd have to extract the columns and store them in independent vectors in order to work with them. Okay, so in Mathcad Prime, we can have mixed units within a matrix or mixed dimensions within a matrix. Okay, and so this alleviates a lot of problems. Okay, so we can have mixed dimensions / units within a matrix. Okay, that means, okay, I'm just going to put a note here that says before prime, and this is also before prime. Okay, and so now that means, let's put a matrix in here. Okay, I'm just going to do a 3 by 2. Now I can have units of force in column 1, okay, 4 kips, 2 kips, 8 kips, and I can have units of square inches in column 2. So we're mixing force and area in a single matrix. We couldn't do that before. Okay, so 40 inches squared, 50 inches squared, and 60 inches squared. Okay, so now we can have mixed units within a single matrix. Now there is no need to separate this matrix into independent column vectors in order to be able to use the data in calculations. There's no need for that. We can assign this to a variable. Okay, we'll just call it data again. Okay, and so now you can see here, there's our data matrix, and now we can automatically just extract columns from that data within the equations. We don't have to first go through the process of separating everything out and storing everything in independent vectors. Okay, so this is a big change. So mixed dimensions / units within a matrix. The second thing is that we can easily add rows and columns. Okay, this was something that people always struggled with. They always struggled with this when using matrices and arrays in Mathcad. So if we want to add another row to this, we have some new functions or some new operators at the top. We can insert a new row above, below, to the left, to the right. We can delete a row. We can delete a column. Okay, so straightforward, but these are things that were long overdue, and they're here now. So let's just put another row beneath. Okay, and so now we get placeholders. Now I can put 9 kips here, and I can put 70 square inches here. Okay, so now I've updated my data matrix, and that's going to update all of the calculations that follow. Okay, so that's number 2. And the third thing, and this is not exactly technically a matrix, so I'm going to just create something called data tables. Okay. And a data table is a new type of structure in Mathcad. Okay, and this is brand new in Mathcad Prime. Okay, this was not in Mathcad 15 or before at all. Okay, this is brand new in Mathcad Prime, and it's called a data table or a spec table. So let's scroll down and give ourselves a little bit of room here. Okay, actually I'll go to the next page. So again, data tables are completely new. And what a data table allows you to do is create a table of input, a table of numbers that looks very much like how you would create columns of numbers in a spreadsheet. So with a data table, you can give your columns of numbers headers at the very top, okay? Give the columns headers, and those headers translate into variable names that will store that column or vector of data, okay? You can also specify the units in the header, and I'm going to show you how this works. Give columns headers, okay, with specified units. Those headers translate into variable names. Okay, so what that means is we can create a data table. So we're going to go to our matrices tab, and we're going to insert a table. Okay, now this is different from a matrix. The matrix is on the left, the table is right next to it. Now we're creating a data table. So I'm going to create 2 columns. Okay, and so now here I can give this column a header. So I'm going to put in force. Okay, that is going to translate into the variable name that stores that column of numbers. This is going to be called area. For the units for force, we're going to put kips. For the units for area, we're going to put square inches. Now we're going to put in the numbers. Okay, so I'm just going to tab through here and just put in a bunch of random numbers. Okay, all right. So now, what happens here is force becomes the name of a variable that stores the column of numbers here in this column on the left-hand side. Area is the name of a variable that stores a vector for area. So we could just come right here and type force equals, and we're going to see the column vector for force. Okay, we're going to convert the units to kips because that's what we're interested in. We're going to display the area. We're going to convert those units to inches squared. Remember in Mathcad we can convert units. Okay, and those are our 2 data vectors. Now we're ready to do our work. So we can calculate pressure by dividing force divided by area. Okay, and we're going to get a column of a vector of output. So I'm going to convert this to units of KSI because I can. Okay, and there's the conversion to KSI. All right, so this is a data table. Okay, and just like with a matrix, within a data table, we can add rows, we can add columns above, below, to the left, to the right. Okay, so that's the data table, brand new in Mathcad Prime, and it's very, very slick, and it's good to be able to create these data tables just like in our heads. This is how we would write this down on a piece of paper. We would create, if we're sketching out a calculation, this is how we would do it. And we always want to give our columns unit labels. Okay, naturally that's the way that we think, that's the way we want to work. So now in Mathcad Prime we can do that. Okay, so let's keep going. So now we're hopping over to the plotting tab. The plotting tab, I'm going to come back to 2D plotting, but the plotting tab basically has all of the hooks that you need to create 2D plots and 3D plots. And so the main one here that to start out is the Insert Plot button. And so when you click on the Insert Plot button, you're going to be able to create plots here. Okay. Let's go on. Formatting. One thing I mentioned is that a key focus area of Mathcad Prime 2.0 is in the area of documentation. Okay, we wanted to make it so that engineers don't have to go to another application to be able to create documents that are worthy of publishing and distribution. Okay, so there's two tabs that come into play when it comes to creating those kinds of documents. One is the formatting tab, the other is the document tab. Okay, these are the 2 tabs that are the key tabs in order to be able to create really cool looking documents. So the formatting tab, the left-hand side of the formatting tab, I would say if you look at my cursor, the left half of the formatting tab from where my cursor is positioned to the left, That's all text-based formatting. Okay, so anything we want to do with our text objects, if we want to change the font, if we want to highlight things, if we want to bold things, underline things, change the size, bullets, things like that, that's on the left side. The right side of this formatting tab is all of your math-related formatting. Okay, formatting numerical results, formatting the display of complex numbers, formatting how many decimal places of precision you want to display, formatting what your variables look like, formatting what your units look like. Okay, the right-hand side is for math formatting. So when you want to format something, you go straight to the formatting tab. Okay, in prior versions of Mathcad, you would double-click, you would bring up menus, you'd go to, it would be quite a number of operations with the keyboard and mouse. Now, it's one click away. You go straight to the formatting tab. Okay, text formatting is on the left, math formatting is on the right. It's that straightforward. Okay, so now if I wanted to format this, I'd just go up here to the left, and then I'd change the size, or I'd change the style of the font. Okay, that's it. If I wanted to format this column of vectors for calculating pressure, I'm going to the formatting tab, and I'm going to the right-hand side. And instead of displaying general notation, I'm going to display these numbers in engineering notation. So I click on engineering notation, and now I've displayed my pressure vector in engineering notation. Okay, so it's super easy. It's completely optimized. Text formatting is on the left. Math formatting is on the right. That's all there is to it. Okay, so that's just something to keep in mind. Now, when you're creating documents that you want to print to PDF, print to hard copy, you're going to use the formatting tab. You're also going to use the documentation tab. Okay, the document tab has everything that you're going to need to be able to define the structure and the look of your document. Okay, and so here I mentioned text blocks and text boxes, two different types of text objects in Mathcad Prime. These are also on the Math tab. Let me just click on the Math tab. Okay, they're right here on the Math tab. They're also on the Document tab. So I'm going to spend a minute clarifying the difference between those, because this is new in Prime. Okay, we didn't have two different types of text objects in other previous versions of Mathcad. There's the separate regions. We all know that we get into situations where we have overlapping regions. For example, when we're doing our work, we could just get, that's overlapping. Okay, so if that happens, we just draw a box around everything, click on separate, and Mathcad will separate things out. We can add page breaks, we can add space, we can remove space. There's two views in Mathcad when you're working. There's a page view and there's a draft view. Okay, this is new in Prime. The page view is basically the view that we're looking at right now. We have page view selected, and this is the print preview of the document. Okay, so this is the print preview. There's no more going to the file menu and selecting print preview. It's right here on the document tab under view. Okay, so this is what we're going to get when we print. Draft view is your working version of the document. So if I click on draft view, I can see my non-print margin. Okay, here's the gray line. Everything to the right is non-print. That's a good area to make comments to yourself. Let me scroll back up here. Okay, you can see where the page breaks hit. Okay, you can see these dotted lines. You can basically see how the document is laid out, but obviously none of these dotted lines are going to print. Okay, so that's draft view. That's the working version of the document. So I'm going to go back to page view. There's also a zoom slider right here too, which you get in a couple of different areas. So also on the document tab, we have headers and footers. Okay, for those of you who have used Mathcad in the past, you know that headers and footers were extremely difficult and cumbersome to put into your Mathcad documents in version, basically every version of Mathcad prior to Mathcad Prime. In Mathcad Prime, we have implemented a very easy to use interface for headers and footers. Okay, so I'm going to click on this. When I click on headers and footers, I can select the header submenu, and that is going to put me, let's go back up to the top of the page, into this header space. Okay, now you can see here, the worksheet itself is grayed out. I can't work in the worksheet because now I have activated the header space. I can work in the header. Okay, so you can see my cursor. I'm just hopping around in the header here. Okay, and so in this header space, I can put in a text object. Okay, I'm just going to put in Prime 2.0. I can format it. Let's go to, now remember, we're going to the Formatting tab, left-hand side. Let's make that much bigger, and we can highlight it if we want to, I suppose. Okay, so there, it's yellow now. And so now we're in the header space. Okay, so there's that. I can put the author of the worksheet, so I'll just put, author Angie. So you get the point. Okay, you can just copy and paste your logos into this header space. You can put tables into this header space. You can put, author, date, project, anything you want, and you're looking exactly at the header. Okay, you're looking at your workspace to work with. That prior process that we had of putting headers into your Mathcad file has completely gone away. Okay, so there's going to be no more struggling with headers and footers. So let's get out of the header. Okay, I'm going to get out of the header here. So when I click out of the header, let's go back and look at our worksheet. So there's the header. Okay, I'm going to go down to page 2. There's the header on page 2. Page 3, there's the header on page 3. Okay, the same is true for footers. Okay, so let's go back into header and footer, go to footer. Okay, now the worksheet is grayed out because now we have to work in the footer. So if we come down here on any page of the document, we don't have to be on page 1 or page, page N. Here's the footer space. So in the footer space, we can put anything we want in the footer space, and we're looking at exactly what we're doing. So, we could put the page number, page X of Y. Okay, so there's page 2 of 3. We just move this object around. We drag and drop it to wherever we want it to go. Okay, also in the footer, we can put the save date, the file name, the path to the file, other things like that. Okay, so those are all things that are going to go in the footer. So now let's deactivate the footer space. So we're going to go back to the worksheet. Now you can see page 2 of 3. If we go down to page 3, we're going to see page 3 of 3. Okay, so those are headers and footers. Those are on the Document tab. They will change your life in Mathcad. Now, going back to this differentiation between text blocks and text boxes. Okay, so text boxes and text blocks. This is new in Mathcad Prime. The fact that we have 2 different types of text objects is a new concept. Okay, so in prior versions of Mathcad, we had something called text boxes, and those were free-floating text boxes. We still have those in Mathcad Prime. Okay, so I can click on text box, and it's going to put in a text box or text region. That's what I've been doing for the duration of this presentation. I've been using text boxes. Okay, so in this text box, I'm going to type in, assumptions or, whatever it is I want to document. Okay, that's a text box. The thing with text boxes, there's a couple of properties of text boxes. One is that when you create a text box, it's a small box, okay, and it starts out as being 1 line. Okay, now if we want to add some, what I'm going to do, let's move this text box up here. Okay, so now if we have 5 or 6 assumptions, I'm going to go to the next line. I'm going to put 1. I'm going to go to the next line. So I'm just using the Enter key, 2. Let's say we have 6 assumptions. Okay, so this is what happens. A text box behaves exactly like a whiteboard. If you went up to a whiteboard and you started writing things down, anything that you have afterwards will not automatically move itself. You have to erase it and move it. So in Mathcad, text boxes behave in very much the same way. So now here, as I've entered in items 1 through 6 for my 6 assumptions, this text box down here called text boxes and text blocks, that didn't automatically move itself like it would in Microsoft Word, for example. It stayed put. Okay, it stayed put just like it would if we were writing something on a piece of paper or on a whiteboard. Okay, so we end up with overlapping regions. Okay, and so now we're going to draw a box around those items, go to the, where was it, Document tab, click on Separate Regions, and we can still separate them, and that's, that's great. So a text box behaves in this manner. Now, it doesn't push everything down beneath it that follows. Okay, we can resize it horizontally. We can make it bigger horizontally. Okay, so text boxes are very good for annotating, annotating design parameters, good for making notes here and there. They're good for sticky note, I like to say sticky note style type of comments, okay? Okay, that's how you should think of text boxes. If you want to put a sticky somewhere, if you want to just make a quick annotation somewhere, if I want to just put a quick note next to this area vector, I'm going to use a text box, okay, because it's a free-floating box. I can move it around easily. And so those are things that text boxes are good for. And they don't automatically push down content that follows. Okay? All right. So those have always been in Mathcad. They're still in Mathcad Prime. Text boxes, and I'll put a note here. Okay, text blocks are different. Okay? Text blocks are different. Text blocks, when you put in a text block, it's not going to put in a small box. It's going to put in a box that spans the entire width of the page. So when I click on text block, and these have keyboard shortcuts, by the way, it puts in a structure that spans the entire width of this page. It goes all the way across the page. Okay? That's one thing. Also, if I have 6 assumptions here, I'm going to copy this. Okay, I'm going to copy this. Let me copy this. I'm going to copy that. I'm going to paste it right here. Okay, and let's put it in a text block. Okay, now if we have 6 assumptions, when we're using a text block, it will automatically push down content that follows. So let's put in our 6 assumptions. Okay, carriage return 1, 2, 3, and you can see it's pushing down everything that follows. Okay, so this behaves more like a word processor type of environment. Okay, so this automatically pushes content that follows. Okay, you can see here I'm using a box. All right, it automatically pushes down content that follows, and its real design is to be used more for documentation that you know is going to take up multiple lines. Okay, if you're writing a report and you anticipate using writing a paragraph, like an introduction, a conclusion, then you should be using text blocks. Okay, always use text blocks if you're going to be writing larger descriptions, paragraph style, explanations. If you're going to be using things like bullets within an explanation, use text blocks. Okay, but if you're just doing like little annotations, little notes here and there, sticky note kind of stuff, then use text boxes. But the real value is that you have both, and you don't have to use one or the other within your document. You can mix and match them, and you can use boxes when you need to. You can use blocks when you need to. Okay, but the fact that we added text blocks to Mathcad Prime addresses a lot of the frustrations that people were running into when they were documenting their work in Mathcad. Okay, they were ending up with overlapping content all over the place, and it was turning into a formatting struggle. You know, people were spending too much time cleaning up their documents because they didn't have a way to automatically push down content that followed. Okay, so we wanted to provide that ability while also maintaining the traditional whiteboard environment that Mathcad is so popular for. Okay, so that's why we have two choices now. So you choose the one that works for you depending on what you need to do at any given point in your Mathcad document. Okay, so we've gone through all the tabs. Now the takeaway here is that if you need to format something, if you need to create a plot, if you need to go to a function, if you need to import Excel data, you're going up to the ribbon and you're going up to the appropriate tab and you're just clicking on the necessary buttons or operators, okay? There's no more double clicking on plots. There's no more double clicking on numerical results to format it. All of that has been optimized into this ribbon, okay? It's very easy to find things. So I'm going to pull up an example of a Mathcad document in Prime 2.0 just so that you can see what a completed document looks like in Prime 2.0. This is a beam loading example. Okay, I'm going to walk through it very quickly, and then I'm going to go through the conversion process, converting your legacy Mathcad files into Prime 2.0. Okay, and then we will wrap up with a Q&A. So let's just take a look at this beam loading example. And I'm going to go to the document tab and I'm going to go right into page view. Okay, this is a deflection and a beam. I'm going to go straight past this cover page, so bear with me while I scroll down here. Now, there's a few things going on here that leverage some of the things that we've talked about so far. Okay, so you can see here we have the we have the schematic. Okay, we have some definitions: the base, the diameter, this equation for I, the area moment. Now we're reading in Excel data. Okay, read Excel. We talked about how to do this. Okay, so you're going to read in Excel data here. Okay, we're reading it from this sheet called Moduli. We're storing it in an array called eData. Okay, when we display eData, basically we're importing these specific property values for these different materials. Okay, and we're going to use those in the calculations. So you can see the units here are navy blue, italicized, bold. I forgot to show you where that is. I'll show you momentarily. Okay, and then we're just going to go through and set our variables and write down the equations and create some plots. Okay, so the length of the beam is set to 15 meters. The required load is set to 500 newtons. The load position is 11 meters. So let's just keep going. You can see the footer. Okay, you can see the footer here, page 2 of 8, marked internal, red 51. Let's keep going. So here are some of the equations. By the way, you probably noticed by now there's a grid, an engineering graph paper grid in the background. Okay, I forgot to mention that. So if you look really closely, there's a faint light blue grid. Okay, and in this case, the grid size is set to fine. There's two settings for it. This is on the document tab. Okay, and it's on, where is it? Is it on? Yeah, it's on the page sub-tab. And right here, there's a button called Show Grid. If you don't want the grid, then you can turn it off. But the grid is the traditional engineering paper. Okay, the green engineering pads, or sometimes they're orange. That's what this grid represents. So it's larger squares containing smaller squares. And this really helps with alignment. Okay, it helps with aligning things. It also helps with, the documents look like engineering documents. You can turn the grid off if you don't want it. So if I just click on that button, the grid's going to go away, okay, and then we don't see it. And if we want the grid, we can always just turn it back on, okay. You can also set in that box whether you want the finer grid or the standard grid, okay. So I wanted to point that out because everybody's probably looking at this document and seeing the grid, and I didn't mention where that came from. So that's new in Mathcad Prime 2.0, Mathcad Prime. Here are some equations for shear, for moment, for deflection, okay? Let's go ahead and go down to the plots. Here are the plots. So this first plot is the plot of the shear. And you can see here we're plotting x on the x-axis, which is the position on the beam, and we're plotting the shear on the y-axis. With plots, okay, this is new in Mathcad Prime, and this is huge. We can put the units into the X and Y axis definitions, and the plot will scale the X and Y axis to whatever unit you put in here. Okay, so we're saying let's plot X in meters. Okay, the position on the beam in meters. Let's plot shear in newtons. Okay, that's why there's an N there for newtons. Okay, so we're scaling the axes, the X and Y axes, to meters and newtons by putting those units definitions right into these placeholders. This is new in Mathcad Prime. Okay, I want to be very clear about this. This is a new capability in Mathcad Prime. In older versions of Mathcad, you could scale the axes, okay, but you had to apply a mathematical trick, okay, that wasn't obvious, wasn't intuitive. You had to know how to do it. It wasn't like this. It wasn't intuitive. It wasn't clear. Okay, it created a lot of confusion. So here it's clear. It's clear that we're plotting X as the position in meters. We're plotting Y as the shear in newtons. Let's go down. Okay, there's the moment. And you can see here we're plotting X in meters. We're plotting the moment in Newton meters. Okay, and then this goes on to just summarize the data. And finally, we're plotting the deflection. Okay, now on the plot of the deflection, okay, you'll notice that we have a couple of vertical markers. We have a marker at 8.35. We have a marker at 11. Okay, those are call-outs. So in Mathcad 15 and before, you could have 2 markers in the X and Y directions at a time. In Mathcad Prime, you can have 8 markers at a time in X and Y. So if we go to the plotting tab, anytime we're working with plots, we're going to go straight to the plotting tab. Now, here, if I select the plot, I can add another marker. I can add a vertical marker. I can add a horizontal marker. So if I add a horizontal marker, it's going to go left to right. In this box, I'm going to put in a specific data point that I want to mark. So if I want to mark -10, I'll put that in, and the marker is going to go to -10. So when you're doing your work, you're probably not going to put in numbers into these call-out boxes. You're going to put in functions like the max of the data set, the min of the data set, the average of the data set, things like that, and automatically those markers will readjust themselves accordingly if your plot changes, if your data changes. Okay, so again, in prior versions, you were limited to 2 markers in either direction. In Prime, you can have up to 8 markers in either direction for a total of 16 markers at a time. Okay, so to customize what this plot looks like, again, very, very easy. If I want to change that line from a blue line to a red line, we're going to go up here. We're on the plotting tab already. We're going to go to Styles. We're going to go to Color, and I'm going to select a different color. Okay, so very easy to do this. So now it's red. If I don't like red, I'm going to go up to Styles. I'm going to go to Color, and I'm going to select green. Okay, and so that's how straightforward it is. It's, again, no more double clicking, no more going through a bunch of tabs, no more clicking OK 5 or 6 times to get back up to your document. If we want to add symbols, we just add symbols here. If we want to add change the style of the line, we can change the style of the line. Okay, so all of that is up here. You can also keep all of these submenus up if you want to, so you don't have to go through and bring down the pull down the way I am right now. So that's the 2D plot. Now, if you want to add more traces to this plot, you just go up here, you click on Add Trace. You can add another trace. We can plot y of x. We can plot basically the deflection shifted down by 1. If we wanted to do that, we're going to keep millimeters. And I'm not sure what I did wrong there. I don't think I put that equation in right. That's okay. I'll have to come back to that and figure out. I think I messed something up with the parentheses. Okay. Okay, so that is Mathcad Prime 2.0 in a nutshell. So now let's take a look at migrating our existing documents into Mathcad Prime. Okay, so what I'm going to do is go back up here. This is the document we've been working with. On the Input-Output tab, there's something called an XMCD-MCD converter. We're going to click on that button. When we want to bring legacy worksheets into Mathcad Prime, we have to run them through this converter, okay? And it will convert the Mathcad legacy files, 15, 14, 13, 11, whatever version it is, into Mathcad Prime's format. Mathcad Prime has a new data format. It has a new XML schema format. So we have to run it through this converter, okay? And this converter comes with Mathcad Prime. So we click on that. We add worksheets. Okay, I'm going to click on this control valve design worksheet. Okay, we can select many worksheets at one time. We can load this up with a bunch of worksheets if we wanted to. It tells us what the original version was. And now we're going to click on convert. And this will start the conversion process. Okay, the new file extension for Mathcad Prime is MCDX. Okay, it's not XMCD. It's MCDX. So we run this through the converter. We get a status called converted. And down here we get a conversion log. Okay, this tells us anything that we should know about how this file converted. So it tells us it was converted at this date, at this time. The source file was version 14/15. This was the path. This is where the new file is being placed. And it tells us 13 out of 82 regions contain differences. A region is an object, a math object or a text object. Okay, those are all regions. It's saying 32 contain differences, but then it breaks it down and it says out of those 13 differences, 11 are display differences. Okay, and 2 are formatting differences. So there's a superscript somewhere that didn't convert into a superscript. You know, that kind of thing, that's okay. And so basically all 13 differences are display differences. Okay, so now we can go open that Mathcad file, the converted file, and take a look at it. Okay, so we're going to close this. Now when you convert the file, it will automatically create a new file for Mathcad Prime, and it will put it in the same directory as your original source file. Okay, it's going to put it in the same exact path, and it's going to have the same name before the file extension. So our new file is going to be called controlvalvedesign.mcdx. Okay, so it's going to create a new file with the same name, different extension, and it's going to put it in the same location. So let me close this. Actually, I'll leave this open. Okay, I'll leave that open and I'll just move it down here and I'll just make it smaller. Okay, so now I'm going to go up here and I'm going to open the new file. So I'm going to open, I'm going to browse for where that path was, and let's see here. Okay, here is our original file. Oh, I'm sorry, I need to display all of these documents to see the original file. Here's the original one, Control Valve Design XMCD. Here's the new one, Control Valve Design MCDX. Okay, so let's open that. Okay, and here is the converted file. Okay, and so it looks like we're coming up on past the hour here, so I'm going to go very quickly so that we can wrap this up and take some questions and answers. So you can see this converted into Mathcad Prime. Anytime, let me just scroll down slowly. What I should do is show the original file. Let me show the original file as well. I'm going to bring up Mathcad 15 real quick here to show you what the original file looked like. And I should have done that up front. I apologize. Okay, so here it is. Here's the original document. This is Mathcad 15. This is what we just converted. Okay, it's a control valve document. You can see here we're defining fluid properties. We're defining pipe system conditions. There's a lot of text boxes here. These are math boxes with units. Okay, let me page down some equations. Okay, this is a pretty advanced. Here's a plot. Okay, pump and system curves we're getting into, the pump head curve, the system head curve. You can see there's 2 traces there. There's the plot. Let's keep going down here. There's the second plot. Okay, we have 4 traces or 4 data sets being plotted here. Okay, and here's the, here's the third plot, the pump head curve, the system head curve, and the system with the control valve. Okay, and then the final plot down here. Okay, so this is the document that we're converting. Okay, so you can see here that there's 5 pages to this document. There's a lot of complex stuff going on here, a lot of advanced calculations, a lot of documentation. This is a very, very comprehensive document. Let's close this and let's go back to Prime so we can see how this converted. Here's the Prime document. Okay, so in the Prime document we have, again, the fluid properties. You can see here, I'm going to go to the calculation tab and calculate this. You can see here the definitions. However, in Prime, the units come in with the custom styles for the units that we have defined for our worksheet. Anytime there's a difference, remember there were 13 differences. Anytime there's a difference, Mathcad Prime is going to identify the location of the difference with a red horizontal line starting at the section that contains the difference, an arrow on the right side that points to the difference, okay, and then if you click on the line, it tells you what the problem is. It says superscripted text was not converted as a superscript, okay. So in Mathcad Prime, at this point in time, we don't have superscripts within text boxes, okay. We have them within math. So you could have superscripts on any variable definitions, but in the text objects, we don't have superscripts at this point in time. We will. So anyways, so that is what that is defining there. And every single one of these is related, in this case, to the same display definition. So let's just scroll down. So what you want to do is you want to come down through here. There's the first plot, okay, and you can see the plots in Mathcad Prime, to tell you the truth, look a lot better than they did in Mathcad Classic. If I want to change the style of those lines, I'm just, as we know, I'm going to come here to the thickness. I'm going to make that red line thicker, okay, and then I can do the same thing for the second curve. I can make that thicker as well. Again, it's really super easy to do this, okay? So I've just modified my plot and it looks so much better. So let's keep going here. Okay, you can see the equations there. And then this is the next plot. This is the one that has 4 traces. Okay, and so I'm just going to scroll down to the bottom. There's the third plot. Okay, and there's the final plot. Okay, so there's the converted document. Once you've gone through and you've verified that you're happy with it, and you've looked at all of these arrows, and you've verified that, you know, it's just a warning and you've read it and it's fine and everything looks good, then you can go back up here to your Input-Output tab and clear the annotations. Okay, this is going to clear all the flags pointing to the differences. So you can clear those. It's going to clean it up. It's going to get rid of all of those red arrows, all of those vertical bars, and now you have a perfectly clean document that you can work with in Mathcad Prime. So that's the conversion process, okay? And so to convert documents, one requirement is that you have to have Mathcad Prime installed, obviously, and you also need to have Mathcad 15 installed on your machine, okay? You don't need to use it, you just need to have it installed because they're 2 different file formats. And so to be able to convert from one file format to the other file format, both applications have to be resident on the machine that you're using. Okay, so that's it's just something I wanted to make sure everybody was aware of. I'm sorry that we went over the time allocated for this presentation. I'd like to thank each and every one of you for coming today. Thank you so much for your interest and for your time. We are going to open up the lines for Q&A. I'm going to pause and say, if you want further information on Mathcad Prime, if you want to go into a more detailed discussion of Mathcad Prime, then please contact your reseller and they can arrange that for you, okay? So go ahead and contact them to take this one step further. If you'd like to order an upgrade, if you'd like to get started working with Mathcad Prime, please contact your reseller. Thank you everyone for your time today and have a great day. Deb, we can go ahead and open up the lines for Q&A.
Angie, we can now open the lines. People have written in their questions, which I've transferred over to Matt. Matt, are you on the line?
Okay.
I guess he's not. Okay, let me try. Oh, you got them? Okay, great.
All right.
You have the questions?
There are a bunch of questions. Not sure how much time we want to take, but sort of grab a couple sort of at random, if that's all right, Angie?
Yeah, that's fine, Matt. How many questions do we have? 20, 25, something like that?
Somewhere in that number. But what we can do, we can also go ahead and respond to the individuals that ask questions with answers.
Yeah, we can do that. We can take a few questions live, and then for the remaining ones, we can just respond via email.
All right, so here's one question. Mathcad 15 has templates for defining document style, but it does not appear in Prime. Will templates be added in later versions?
Templates are going to be available with the next release of Prime. They're not in Mathcad Prime 2.0. The standard template format is something that's coming. It's on the roadmap and it's coming.
So I'm interested in using a title block for my calculations. The title block spans the entire page. Is there a way to use title blocks like this?
What was the last part of that? Is there a way to use title blocks?
Like that, like that.
You can use, yeah, you can use, if I'm understanding the question correctly, I think you can accomplish that using the text block, and that will be able to span the entire length of the page, and you can set it up for your title block that way.
We'll take a couple more. Can you create data tables based on rows instead of columns? And can you specify labels for both rows and columns?
No, you can only set up data tables for columns, and you can only set up labels for columns, not rows. Next question.
So that so can you use a combo box from Excel to Mathcad 2.0 when scriptable objects?
At this point in time, there are no scriptable objects in Mathcad Prime or combo boxes like you have in Excel.
We'll grab one more. Can you discuss the improvements that have been made regarding Mathcad Prime's integration with Creo Parametric?
Yeah. So the integration with Creo Parametric is bidirectional. It's based on the same integration concept that was designed for the integration between Mathcad and Pro Engineer. It's based on bidirectional data transfer. In Mathcad, actually, let me go back to my input and output tab here. The way that this works with Creo Parametric and Mathcad Prime is that when you have a variable result in Mathcad that you want to use to drive a dimension in Creo, you're going to click on Assign Output. Okay, so I think that in this, I'm not sure, if I have a variable A, I'm just going to define it, set it to 40 centimeters. If that's driving a dimension in Creo Parametrics, okay, 0.4 meters, I'm going to click on this. I'm going to click on Assign Output, okay, and now that's designated as an output. So now when I go into Creo Parametric and I configure the Mathcad analysis feature, it's automatically going to pull in A as 0.4 meters from Mathcad, okay, and then I can associate it with a dimension in Creo. So this is completely new, because in prior versions of Mathcad and of Pro Engineer, there were no assign input, assign output buttons. You would actually have to put in custom tags to the Mathcad variables, okay, and that was a very cumbersome and tedious and not a clear process at all. So now you're assigning inputs and outputs. It automates everything. If you have a parameter from Creo Parametric coming back into Mathcad that you want to use as an input to a Mathcad validation calculation template, you're going to assign that as an input, okay, as an input. And so that's one fundamental improvement between the integration between those two applications. I think to go into it in more detail, we probably should have you schedule a specific demo for that. But that's one of the main improvements. Go ahead, Matt, with the next question.
All right, and just if it's all right, maybe we'll take two more, and then if we didn't get to your question, we will reach out to you and answer it for you.
Yeah, that sounds good.
So will custom units of measurement have the same style as built-in units?
They will. They will. Custom units, and I think you're talking about the styles. Let me go back over to formatting. This italicized blue bold style, that is set over here, okay? And you can set those styles, those are called label styles, for variables, units, constants, function, system, and keywords. So you can see my units are set to this navy blue italicized bold. If I want to change that, I'm going to change it right here, okay? Change it to orange. Now my units are orange, okay? So that's how you set that up. You can set that up for variables as well, not just units. My focus today was on units, but I want to make sure everybody understands you can set those up for variables. So anything that's a variable, you can say I want to make all of my variables bold, and I want to make them red, so it's really clear what's a variable. Okay, so now you can see A here is bold and it's red. Okay, so that's how you set those label styles up, and that will extend to custom unit definitions as well.
All right, thanks. We'll take one more. Will Prime do surface plots with 3 variables?
Yes, Prime 2.0 will create surface plots with 3 variables. It will. So that has been added. I can just go back here. If you have 3 variables, okay, so in this case, the short answer is yes. I know we're running out of time. But if you have a function that has 3 variables, okay, so x and y are the independent variables here. Z is the calculated result, f of x, y. Okay, so conceivably you'd have 3 column vectors, 1 for x, 1 for y, and 1 for z. You could plot that. You could create a surface plot of that in Prime. Okay, so again, you just go over to your plotting tab. You'd go to Insert Plot. You'd click on 3D Plot, and then you'd plot your data, and you'll get a surface plot. So
well,
Matthew, do you want to?
Angie, appreciate it.
Yeah, you're welcome. So why don't we just go ahead then and capture the remaining questions, and we can get them answered individually, via email or however we want to go about communicating back those answers. Does that sound good?
Sounds great. Thank you very much, Angie, and thank you very much, everyone that stayed on the line. Hope it was informative. And if you have more questions, obviously go ahead, reach out to your reseller, and then we'll assist.